How y'all doing today?
Good morning. Good morning. Good on this side. Great.
Morning.
All good. Did soccer this morning, so we're back and ready.
Oh, nice. You get started in like 2 or 3 minutes. Today's session is going to focus a lot on tools. Probably a lot of the tools you've seen before, but just want to cover them again and how to use them from a auditing perspective. Miles is on a plane right now, so he may join in the second half, but he'll be here again next week.
Wasn't Miles flying last Saturday too?
Yeah,
Flies a lot.
yeah. He just got back to the States because he was in Colombia for 8 months. Yeah, he just got back to Atlanta and starting to visit family around the Southeast.
Cool.
Have y'all gotten a chance to do the CTFs from the last session or go through the audit report?
I haven't. With the new job, it's like I don't have a lot of time, so I was planning on trying to do it this weekend.
Oh, how's it? Hope that's been going well.
Yeah, thanks. It's been good. And with the new job, you gotta
Yeah.
you gotta hustle at the beginning and figure out a whole bunch of things. So that's sort of where I'm at. It's getting better, but by the time the day's over, it's like spend a little bit of time with my daughter and then crash and
Makes sense.
then do it again the next day. But yeah, I'm gonna check that out this weekend.
Cool. So I think we can go ahead and get started. So welcome to session 3 of the Web3 security course. So today, like I mentioned, we're going to be focusing a lot on some of the tooling you use during the audit process. And these tools are also just used in general for Web3 developers to build things. So first, the tools we're going to go over are Hard Hat, Remix, and Block Explorers, and just how to navigate around those. And we're going to go through an exercise of actually using Hard Hat to show how you can use it to solve Ethernet challenges by writing tests and writing contracts to actually exploit those. And then we're going to go through a couple of more attack vectors. May take some time to review the attack vectors we talked about last time, and then talk about another couple. And then at the end, just want some time to go through the concepts of the key concepts from the CTFs from the last session. Before I go ahead, was there any questions or thoughts on this? Cool. All right. So tools we're going to go through today, like I mentioned, Remix, Visual Studio Code, Hard Hat, Block Explorers. I'm going to briefly talk about Tenderly and Defender, but I didn't want to overload with a bunch of tools. So before I go on, have all of you used Remix before? I'm just curious if there's anyone who's never used it before.
Yeah, I'm comfortable using Remix.
Okay. Just to go through it again, I guess let me open it up first before I go through the slides. So if you go on Remix projects on their website, also their documentation is pretty good on all the different things you can do. But it's one of the easiest ways to actually start writing Solidity and deploying things like to real, test nets or main nets. It's a web-based IDE, and has a lot of cool plugins that make it very easy to write smart contracts or interact with smart contracts. Specifically for auditing, I really like it for like being able to quickly iterate on like ideas. Maybe also if there's some contracts on chain that I want to interact with, you can load them inside of Remix. So if you haven't seen Remix before, I just opened it up here. I have a few contracts already loaded in here. The 3 sections here are where your files are. There's a section for, if you want to write smart contracts or add new smart contracts, you can do that here. You can also, add your dependencies as you need to import different libraries. There's also this section where this is where your code can be compiled. And so one of the cool things about this is as you're building the contract, Remix will be, you can configure it to auto recompile so that you can see in real time whether your contract is working or not. And you see, you get some warnings. And if anything breaks, the compiler will let you know. Another really, really useful portion of Remix is the deploy and run transactions. So this is the area of Remix where if you have a contract you want to deploy, to a test environment, to a test net, or even like your local hard hat, you can connect it here. And this is just really useful for one, probing contracts that are already deployed on test nets or main nets. So for example, whenever you're doing an Ethernet challenge, some of the contracts you see here are some of my Ethernet challenges. You can just copy and paste it here. I'll automatically compile it, and then you can actually just find that contract instance and load it here, and have all your interactions be through here instead of through Ethernet's website. So that's one of the ways to use Remix for like security practice. Cool. And that was just a quick run through of Remix. There's a lot more things that I can do, but from a high level, it's a really useful tool for moving fast with writing contracts or interacting with contracts. Anyone have any questions or thoughts with Remix before we go on to Hard Hat?
I think Remix is like pretty cool tool to use like when you just want to compile Solidity into like a usable interface you can just play around with on the go, on the fly. It's a great tool to have to use as a developer.
Mm-hmm. It really is. Another way I used it is if I need to get like a contracts API and like download it really quickly, you can paste the contract in there and export the API in a JSON file, which makes it really easy to get. Sometimes it's hard to get APIs. All right, so the next tool I want to walk through, so Hard Hat is another, I call it developer theory or Web3 developer tool, like framework or tool for like building smart contracts. So before I go into hard hat, is there anyone here who has not used hard hat before or heard about hard hat? Okay, so just to give a quick one through again, like Hard Hat's website is, and their docs are very good. So if you're interested in learning more, I definitely encourage you to read through these. Like most other technologies, Solidity has an ecosystem of like tools and frameworks to make it easier for developers. So in this case, some of the most common tools are Remix, Hard Hat. Another one is Foundry. We're not going to talk about that one. And an older one is called Truffle. And all these tools are basically just trying to make it really easy to build and maintain smart contracts in whatever environment you need. So I like to think of Hard Hat as the next layer up in terms of what you can do as a developer on top of Remix, because Hard Hat introduces things like being able to run a node locally, or being able to fork a testnet or mainnet, all that state into a local node, and then run it locally to actually execute code. It also lets you do things like write scripts for interacting with contracts or deploying contracts, and there's also like testing utilities that really help you write tests. So I wanted to go through Hard Hat from the perspective of how some of the ways that you can use them for Web3 security. So specifically, the first example is for a lot of the Ethernet capture the flag challenges. You can write the contracts and then write unit tests to verify those exploits by using Hard Hat. So I wanted to demo what that will look like. Before I do that, are there any questions or thoughts on Hard Hat? Okay. So I'm just gonna open up an example here. So what I'm showing here is a repository that I have for keeping track of some of the capture the flag levels that I've done. First thing about Hard Hat is you normally start with, it supports both JavaScript and TypeScript. I prefer to use TypeScript, so that's why it's TypeScript, but you can also use JavaScript here. Normally there's a config file where this is where you tell it things like version of Solidity you're using, or if you wanted to connect your Hard Hat environment to an actual testnet or mainnet, you could configure, like if I wanted to do a testnet, you could actually, I can't remember the command now, but you can type in configuration so that when you're running your test or you're running your scripts, it's pointing to this testnet using this URL. So the format of the files here is normally there is a contracts folder, and it's where all smart contracts go normally. There's a scripts folder, and this is usually where scripts go if you're like, say you have contracts, you're writing an app and you actually want to have like automated deployment with tests and a bunch of different things. This is where you would write those deployment scripts. And there's also a test folder, and so I want to focus on the contracts folder and the test folder. So one of the capture the flag, the optional assignments after this session, is one of the levels in Ethernet is about reentrancy. And so one of the ways that, well, one thing about this level, and this one is optional because it requires you to write some Solidity. And so in order to validate that the exploit works, one thing that you can do is write a unit test for that. So I'm not gonna go into details on like what this contract is doing. Just from a high level, once this contract is loaded in here, you can have a separate contract specifically for your exploit. And so that contract in this case, who does not like this formatting, don't worry about the logic inside of here, but I just want to show that it is a contract. There's a method called attack. It's interacting with this contract here. And what you can do is write a test to validate, hey, this exploit actually works. And inside of Hardhat, it is a JavaScript environment, so your tests are written using JavaScript. So in this example here, don't worry about what's happening inside of like the details of how this is working. From a high level, it follows a very similar pattern to Jest. It uses Chai and Mocha as the assertion frameworks, if that's something you're familiar with. And so what you can see here is what this code is doing is loading the two contracts. Like, hey, this is the contract that is the target. This is the contract that's going to exploit. That's all of this code is doing. And then this unit test here is actually running the exploit. So a lot of the times when doing an audit, if you find a high or critical vulnerability, you usually have to validate it by writing a unit test like this. Just because it's like a lot of those high and critical vulnerabilities can be complex, and just like talking through it with words or showing it, code snippets may work, but normally it's best practice to write a unit test to show, hey, I wrote a test. Here's a code that breaks your code. You can verify it 100%, and it can't be denied because it's a unit test. Okay, so that was just a quick run through of Hardhat from the security lens. Anyone have any questions on like how to use this in a CTF, or how to use this in like an actual audit, or anyone have any thoughts they want to share?
I think that testing a contract is like the toughest thing that you could do as or encounter as a developer. So like how do you get better? Like, is there a framework that you can follow? Is there like a repo that we can go to like see like examples of like these attacks being like tested?
Mm-hmm. Yeah, that's a good question. So I think there's two pieces there. The first one is like, how do you get better? And the second one is, finding repos with these examples. So for that first question on how to get better, I think it's similar to getting better as an auditor. Like, it's some part of you have to, start trying to write tests and going through those exercises of trying to write tests. And then the second piece of that is, learning how to write tests. So there are different YouTube videos and like blogs that are helpful with that. But to answer your second question, there are GitHub repos. Let me see if I can find one where they have, they'll have the Ethernet challenges like written in test. Like, they'll have the contracts and they'll have tests. But that also exists for like real hacks that happen. And one of my favorite learning resources are, let me see if I can find it really quickly. It's a catalog of like unit tests for majority of the hacks that have happened in the past year or two. And it's just a really, really helpful resource. I think it's this one. Yes. Yes, okay.
Yes, that's a great resource, and I'm actually learning how to use Foundry. I'm reproducing the same attacks, and that set up my next question. Like, I'm working with Solidity is like already a difficult task. It seems like a little easier to test like the contracts in Solidity versus like testing them in TypeScript. So it's like where to start, because I don't want to jump the gun. I just don't want to just like fall deep into Foundry without really like becoming like not an expert at hard hat, but like polishing up my skills.
No, yeah, that's a good question. So I think if you're already using Foundry, like my general philosophy on tooling in general is like get really good at one before trying to learn another. Because Foundry it's a really good, like I'm in the process of learning Foundry, because one of the things you mentioned is you can write your tests in Solidity, and a lot of their test helpers are, I find, a lot easier to write tests with than hard hat. But I think like all tools, there's trade-offs. Like there's some things Foundry's a lot better at than hard hat and vice versa. But if you're learning hard hat, Foundry, like Foundry is on the rise, and like I think if I were to learn it again, I would have learned Foundry first instead of hard hat.
Thank you for clearing that up. That's great. That gives me more confidence.
So just to show like what one of these looks like, so they have these are all real hacks that have happened. And so if you click on any one of these, they kind of have a brief description of, how to run the test, the Twitter references breaking it down. And you can go and look inside of, so these are Foundry tests, meaning that the tests are written inside of, in Solidity. And so you can go to this repository and see like how, the attacks that happen in the real world work. Yeah. And it's pretty common for auditors to write tests to prove, high critical vulnerabilities. And it helps the protocol developers, know how to fix it, because if you have a test case, then, you can quickly figure out how to make it pass, how to make it fail.
Can I just sort of walk through and make sure I got, if you go back to the VS Code.
Oh, yes.
So the general setup here is you want to either set up Foundry or hard hat, your environment first. And then if you want to do an Ethernet challenge, you would just copy the code into, like in this example, it's reentrancy.
Yep.
And then the exploited contract is something you write yourself.
Yep.
Right? Okay. So this is the copy paste reentrancy. This is the one you're writing yourself.
Yep.
For the exploit, and then you're writing the test yourself in I guess this is a TypeScript file.
Yep.
And that's calling both of them and having them interact.
Yep.
To execute the test, and so that's the framework for writing tests in general, at least in terms of with Ethernet.
Yeah. Yeah, that's generally the flow I use. And even in audits, a lot of the times protocols will have unit tests. or they'll have like their unit test. And sometimes you'll see protocols that use hard hat, sometimes they'll use Foundry, sometimes they use both. So another way I like to use unit test during audits is it helps understand how the protocol developers like intend the system to be used. Because there's, sometimes there's like, initial conditions that have to be met when contracts are being deployed, or if they need to set up, if it's a DeFi protocol and they want to test like how they're like something with, like an example could be if there's a DEX that has, multiple liquidity pools and they want to write a test that's like something that, they want to unit test some interaction between those liquidity pools. Like they have to write the setup portion, which will actually get to that point. So reading protocols tests can really help also understand how their system works or how they expect it to work.
Cool, that makes sense. Thanks.
And if a protocol doesn't have tests, that's something that should definitely come up before the audit, because it's really hard to audit something when the developers themselves don't know really what's happening, and it's hard to do that without tests. Ah, cool. So I actually want to show what it looks like to run a test. So right now I think I have 3 tests that will run. So let me open the terminal here. So if you haven't used Hard Hat before, and Foundry has a very similar flow, what you do when you're writing Solidity is first, you'll write the Solidity file, but then you need to actually compile it. So that is, I think it's npx hard hat compile. Oh, so I actually have a shortcut that I used. It's called HH. It's just hard hat. I'm not inside of a hard hat project. Oh, okay. So let me try it again. So let's compile it. All right, so it looks like I compiled it before in the past, and so it's not going to do it again. So now if I run the test, what this command does is it runs every test. It looks to see every, inside of this folder, it looks for all of these tests here. So if I run this, it's going to run all of the exploits. And so one of the processes that I'm doing when I'm doing CTFs, or even when I'm, writing tests in an audit, is I will, have like the exploit code up, or also just the code I'm looking at. Sometimes I'll add logs or change around the logic, and just I probably run tests, like hundreds of times, where I'm testing different ideas and understand things. So it's just a really good, if it's something that you, if you wanted to get better at auditing, writing tests is one of those skills that I think eventually has to come up, because it just helps you understand systems better and validate and invalidate ideas really quickly. Do you want to have any questions on Hard Hat, running the test, or how they're useful, or any misunderstandings?
Hybrid says 3 passing, 1 pending.
Oh yeah. So I put a skip on this test because for some reason it wasn't working this morning. So like if I remove this and I run it again, I think that test fails. Yeah. And one thing you can do if you want to only run a specific test or exclude a test. In this case, if you have a test and you put .skip and you run it, it will be skipped.
Thanks.
Cool. All right. So the last tool we really want to go through is block explorers. So block explorers are useful not just for developers and auditors, but I think even Web3 users, because it is a source of truth of what's happening on a contract. Is there anyone here who's not used the block explorer before? I think that will down influence how I'll talk about it. Okay, so it seems like everyone here has used them. What are some of the different chains that you've used block explorers for? Yeah, if anyone would like to talk about some of the block explorers they use most often.
I mean, Etherscan is the king, and then forks of Etherscan on other chains are a necessity. And the chains that don't have them, it's so hard to sort of pick through what's happening.
Yeah, it's kind of become a industry standard where if there is a chain, and if there's no block explorer, nobody will take it seriously. Yeah. So from the Etherscan.
Like, look at Kanso is a good example of it doesn't look like Etherscan. They don't have a good fork, so
Yeah.
I hate this.
Yeah.
UX. There's other ones that have stuff similar, and it's just way harder to sort of parse when you're used to Etherscan's format.
Mm-hmm. Yeah, I mostly use Etherscan and Polyscan. If you haven't used Polygon much, they look pretty similar to Etherscan. Yeah, I like it. Most of my testnet, I actually use Mumbai, which is Polygon's testnet, just because the faucets are easier and yeah, I like it. Yeah, so from a security perspective, or I guess even just as a usability perspective, I think there's a few key features that may not be super common, but I just wanted to touch on some. So first, let's just look at a random transaction. So right now we're looking at a random transaction on Polygon. So both as a developer and auditing, some of the important areas that I like to look at here are if you usually in a transaction you'll be able to see the raw input data. So important things here, you have your function signature, and this is the actual call data being passed in. One thing you can do to just quickly understand what's happening is you can click decode the input data, and so then you can actually see oh, here's the actual values that are there. Other useful things, you can see if there's an event fired. So on this random transaction, you can see there was a new transmission event, some other events that are happening. So just being those two things, finding out this input data and different events that may be fired, are really helpful in just helping understand what's happened and what data is available. I think another thing, I think this transaction only had one function call. But you can also look at like call stacks. So if you had a contract method that called another contract, and there was like 4 or 5 contract calls, you'll be able to see that inside of that transaction and trace all the data and the gas costs across those transactions. So block explorers are very helpful tools for analysis, understanding what's going on, and also seeing what's available. Anyone have any questions or thoughts on block explorers?
I just shared another tool that's decodes the transactions too that I found just this past week. Actually, it's pretty cool.
What is this one? Oh yeah, I've seen this one. Yeah.
Yeah, it's like VNet and go early though.
Oh, I see. Yeah, I wonder what's gonna happen with Gorilla. All right, cool. So I think it would be good to take a short break, and then we're gonna shift gears and talk about a couple more attack vectors. I think last week we covered 3. Today we're just gonna go over a couple because one of them is a bit more complex. Just want to make sure y'all understand how that works. So let's start again at 12 or in 5 minutes. Yeah. I'm gonna go stretch my legs. start again in a minute. Okay. So last session we talked about, I think we went over 3 different attack vectors. Yeah, someone either unmute yourself, or you can type in chat some of the attack vectors we talked about last session.
Access control was one of them.
Yep, access control is one of them. And then another one was so unchecked math is one, and then we were talking about the underflow overflow specifically last time. Okay, so just to remind you of one of the resources I really like for someone want to say something?
Yeah, I actually found a cool attack, access control attack that happened to MakerDAO. If you would like to read through it, it was a simple attack that caused a lot of havoc, and I actually got to reproduce the attack.
Oh,
I
nice.
just put the link on the chat.
Oh, nice. Yeah, definitely take a look at that one. I wanted to remind you that I think this resource, Bioconsensus, is really helpful because it just helps to. It's kind of like it helps learn what the different common attack vectors are. Because I think most DeFi hacks, or most, not even just DeFi, most Web3 hacks that happen on either the smart contract layer or some aspect of blockchain, like most of them fall into a very small set of categories. So being familiar with them, like access control or unchecked math, just knowing a few of those, you can find a lot of things in real code. So today, the 2 attack vectors we're going to talk about are trusting user input. So last session we talked about input validation. I like to kind of think of this slightly separately, where input validation is, there's like some preconditions for, logic you want in the code to run, whereas trusting user input is, it could be something like, we assume only trusted actors can call this method, or we assume only this contract or like internal things can call this method, and that not being the case. Or it could be a case of forgetting that anybody can call something. The second vulnerability we're going to go through is reentrancy. So this one is one of the more complex vulnerabilities, but I think it's good to understand because it's still one of the most common, even though it's one of the most well understood as well. Okay, so the first attack vector, trusting user input. The name implies essentially what the vulnerability is having functions or logic that could be called with like whatever inputs put in, and you could imagine how that can break a lot of things. So an example. Oops, let me go back. I just wanted to show an example hack here. So this again is a database that I found of most of the hacks that occurred in the past couple years, and there's a lot of, I really like this tool because it adds tags to them on like what the vulnerability was, and so you can see that some of the things we talked about, like access control, reentrancy, like we're going to talk about, they happen a lot. So this specific issue, this was on SushiSwap. You can actually see that proof of concept or the repo I mentioned earlier, they linking to the proof of concept for this hack. But you can see that there's some code inside of, basically there was some code inside of one of the contracts that just accepted like whatever user input. And an attacker was able to take advantage of that to steal ETH. I'm not sure exactly like what, I would have to take time to read through what's going on here. But I just wanted to show that you see that this method is external, meaning anyone can call it. It's payable, meaning that you can send money to it. And you see this input of, you have like an input of array of like just call data, but it's not doing any checking on that call data. It's literally just like taking it in and then looping over whatever you pass in and then calling it to like an external contract. So this is an example of, just blindly trusting whatever is passed into the method, coming back to a hack. Cool. So were there any, this attack vector is pretty general, in the sense that like you can see it in multiple flavors. Like in that case it was a external payable function, but sometimes you can get that with an internal function where the developers building the protocol may not have expected a path someone could take to be able to access an internal method. So that's another place where it pops up, where someone makes an internal method, they're like, yeah, only something internal to this contract can call, but there may be some edge cases where that's not true, and attackers will be able to get to those methods. So even in those cases, it's good to not just trust the input. Before moving on to reentrancy, were there any thoughts or questions or questions on this one? Okay. Cool. So before going to reentrancy, just to get an idea of where everyone's programming background is in. If you're familiar with recursion, could you type 1 in the chat? And if you're not, could you type 2? I was curious to see if y'all are familiar with recursion. Okay. So just to quickly review recursion. So recursion is a programming concept, not just to Solidity, but any programming language, Java, Python, even like low-level assembly. And what recursion allows you to do is essentially have a function call itself multiple times. And inside of the EVM with Solidity, one of the one of the things that you can do is if a contract is making an external call into another contract, that contract that it's calling can, if the method is public or methods are public, it can call back into whatever contract called it. And so reentrancy vulnerabilities are the attack vector is whenever there's a contract that makes external calls to other contracts. Reentrancy is when whatever contract's being called calls back into the first contract to exploit it, like within the same transaction. So if you see this image on the right here is trying to convey what that is. So imagine there is a method here in this contract A on the left where someone calls it, it checks their balance, it sends their funds. If say someone's trying to withdraw money, they could have a method where it first checks the balance and then it's like, hey, yep, they have enough balance, and then it actually sends the funds. And the way it sends those funds is using either transfer or a call or a static call or delegate call, like however they want to do it. And then at the end of that function, it actually updates the state of that contract. Because remember, whenever a contract is trying to keep track of token balances, like they have to keep track of it as a variable and update it. So one way reentrancy occurs is if someone improperly implements like this withdrawal method. What someone can do is they call this method, it checks the balance, it sends funds to whatever address it needs to get those funds from, and in the case of reentrancy, it's usually a contract address. And so whenever funds are sent to the contract address, if you remember from the first session and last session, you can have logic execute whenever your contract receives ether. And so what someone can do is whenever they receive ether, they can just call back into this method, and that will start to execute before the balance gets updated. And so this way they can just keep calling back into this contract to drain funds. And so that's what a typical reentrancy attack may look like. I know there was a lot of moving pieces there, but anyone have any thoughts or questions on this one?
How do reentrancy attacks affect price oracles?
That's a good question. So it can happen in a few different ways. One way that it can happen is say there's instead of having contract A be check balance, send funds, update balance, imagine there was a second step where it was like, hey, get the price of this token so that we know maybe there's they need to know how many tokens to send based on the price. So imagine, just for the sake of this example, between checking the balance and sending funds, there's a step to check the price. One way that it pops up is someone could use a flash loan just so that the price, when this price check occurs during this transaction, it will be incorrect. And then because reentrancy is only occurring in that one transaction, every time that price is read, say they do the flash loan first and then they execute this logic, that oracle will be giving back the wrong price for that transaction. And then they would be able to use reentrancy to actually drain the funds. So that would be an example of a flash loan attack exploiting a reentrancy vulnerability. I know another way is
it's a combination of attacks. That's pretty cool.
Yeah. Another way is I know Uniswap v3 has the first time I heard of it, it was a read-only reentrancy vulnerability. because of the price oracle. And I think it had to do with like the price that was returned depended on so like given a liquidity pool, you had to like ask for the price given like a range of liquidity, and there were some edge cases where you would just get the wrong value, um, and so attackers could exploit that oracle as well, but I don't remember the details of how that one works. Okay. And one of with reentrancy, there's like known ways to protect against it. One of them is called the reentrancy guard, and basically what it means, I've seen it implemented as a modifier. So basically, it prevents the same caller from like calling that contract method more than once inside of a single transaction. Um, yeah. So reentrancy guards are, especially whenever there's a call to external contract, are very recommended. Um, when I'm looking at an audit, if I see that there's a call to an external contract and I don't see a reentrancy guard, like that's a huge sign for me to just look to see for vulnerability there. Um, yeah.
Is there an easy example we can see to see what one looks like, a reentrancy guard?
Sure. Let's see. Should be able to go to. Where was it? Here we go. So Open Zeppelin has one. Solutions. Okay. Let's open Zeppelin. Let's see. Guard. Yeah, so this is one of the utilities here. So this one is a modifier. And so what that would look like is, find one. You would import that library. Here we go. Yeah. So I think Open Zeppelins is, there's a modifier version, and there's also one you can make to an interface that a contract can implement. And then once that contract implements the interface, you can just throw this non-reentrant modifier on whatever function you're worried about, and it will make it so that it's non-reentrant, meaning this same message sender can't just keep calling this one method inside the same transaction. So that's one implementation of it. Usually the modifier route, if projects don't use existing libraries, they'll make their own modifier just to make it a little bit easier.
Thanks.
And reentrancy has been a known common attack vector for many years, but it's still one of the most common exploits. Let me see which one did I link here. Yeah. Cool. All right. So I think that was all for this session in terms of me talking. So I think now we could either, talk about last homework assignment on, if anyone had any trouble or what were some of the biggest takeaways there, or we could, skim through, talk about the auto report that posted from the last assignment. Do any of y'all have a preference on what we would do or what you would want to focus on?
I would rather you go through an audit.
Oh, auto report.
Yeah.
Okay. Oh, okay. I see a question in Discord. What if we had a tool which told us about every token that's recently added the Uniswap pool? Would it be ethical to scan through those newly minted protocols? Yeah. So I think that's a totally valid thing that I'm sure is already happening, both with white hats and black hats and gray hats. So normally, if it's there are tools that I don't know any off the top of my head, but I know someone's built them, or you could build it, where you essentially just look for function signatures. Like you can find the contracts that implement that pool, and that's something that I know attackers do, but also security researchers. Because security researchers do sometimes proactively reach out, like, hey, I know this Uniswap v3 vulnerability exists. Let me try and notify some protocols let me find some protocols to see if it's like commonly aware. And if I find some, usually that's where platforms like Immunify or there's a few other that help you contact the affected protocol in like a private channel and help facilitate that discussion. So Immunify is another public bounty platform where instead of having like time boxed audit context, what protocols will do is they'll say, hey, here's our code. If you find, a low vulnerability, we'll pay you this much, medium this much, high this much. So that is a strategy of finding that vulnerability and then reaching out to the protocol to say, hey, you have this vulnerability, and that's a white hat. Black hats do the same thing, but they try to actually exploit the protocol.
Thank you for clearing that up.
Okay, so let's go through an audit report. When I go through an audit report, I would like for y'all to talk about some of the vulnerabilities. Okay. So I've been posting these issues in the course GitHub. And essentially, each issue is a separate audit report where I've asked that pick one issue and then write like a quick blog about it. So the last session's audit report, this was 100% optional. Most of these assignments are optional if you have time. So this is the Canto contest. So before I start going into this, could you press 1 if you had a chance to go through this, and 2 if you haven't? Just to make sure. Okay, awesome. So I think this would be a good opportunity for y'all to, I guess, pick a vulnerability, and then I would like someone or multiple people to explain the vulnerability, because audit reports are very helpful for learning and like learning attack vectors, learning how to you learn tricks about how people write tests, or just new attack vectors that you didn't even know existed before. So I think it might be easier to start with some of the low or non-critical vulnerabilities. So would someone or multiple people, could you pick a vulnerability that we're gonna go through? Because I'm gonna ask someone to explain that vulnerability to everyone else, just to start training that muscle of how to digest the audit reports. So if you could type in the chat or come off mute, which one of these vulnerabilities we want to try and go through.
I see one, L05, missing reentry guard.
Oh, perfect. Okay. So let me see how much stuff there is here. Oh, not that much. All right. So.
An elementary one.
No, none of this is elementary. Okay. So I'm gonna take a couple minutes to read this, and then I'd like one of you to walk through what the attack vector is and like what is the impact on the protocol based on just this code snippet, and then how to what the fix was. So yeah, just take a few minutes to read this and try and understand what's happening, and then I'll ask someone to go through this. So I'm gonna mute my mic for a couple minutes just so I can read this. Can everyone see it on my screen? Okay. If it's helpful, I can keep my mic on because I also talk out loud a lot when I'm reading these. The transfer is done with address. The send value and withdraw. Withdraw here. Yep, just got the amount. It's public. Only NFT owner. Okay. It checks the balance.
Am I reading this correctly? But did he get a warning during compilation? It says, important because control is transferred to a recipient. Care must be taken to not create reentrancy vulnerabilities.
Yep, that looks like a warning, a compiler warning.
Yeah, they should have took the warning.
Okay. So would someone like to go through this one? So I guess the way to go through it would be talk about what the vulnerability is, and then what the possible impact is, and what this recommendation is saying to do to mitigate that risk. Yeah. Is there someone who'd like to take a shot at this one?
Yeah, I'll take a shot at it.
Awesome.
So looking at this attack, we're looking at a reentrancy attack, and this occurs when an attacker is able to call the same function multiple times before the initial call completes.
Mm-hmm.
To prevent this attack, it would be important to implement a reentrancy guard, which you can see that wasn't implemented in the code.
Yeah. Yeah. So yeah, it's a reentry attack. It was a warning that it wasn't, the reentry guard wasn't added. Um, so one question I have is, why do you think it is a low and not a high? Because typically low vulnerabilities don't have, there's like no risk for like user funds to be lost or.
Is it because the balances are updated before the line is
Yeah.
sent?
Yep. Exactly.
So,
Yep. hmm So even if someone did call this function with reentrancy, it would still operate correctly. Yeah.
yeah, so I mean, is it really do they really need the guard? Like, let them re-enter. Like, it shouldn't drain, right?
Well, that's for this case. But one thing though, I think it's always good to keep in mind is audits are a snapshot. So they could introduce some code at some point in the future where like someone could exploit this vulnerability and like combine vulnerabilities to do something they weren't supposed to.
Got it.
So I think that's why it was a low, because it's like, hey, doesn't look like someone can exploit this now, but it's an easy fix to make. You just won't have to worry about it in the future. Because a lot of, well, maybe not a lot, but sometimes you can combine multiple lows and find a critical. So yeah, in this case, it doesn't look like there's any funds at risk, but still best practice. So these are also, some low vulnerabilities that might be easy to spot in a audit contest. And usually the code smell I look for that is if you have a method that's like externally callable that calls another contract, and the contract that it calls is like, you can pass in whatever address you want. Like that immediately makes me think of, okay, can I have a malicious contract like re-enter this one, or have a malicious contract do something. So that's a code smell that I like to just have in mind when I'm auditing stuff. Also as a builder, and it's like just knowing the difference between, you want to update the state before you actually send ether, because the order of these two lines really matters. So just being aware of that is also good from the developer side.
So is it safe to say that every like withdrawal function should have a reentry guard?
I don't know the answer to that. I think in most cases it makes sense. I'm trying to think if there's any that doesn't. Yeah, I think most should, but I wouldn't be surprised if there's some that can't.
Or can we just handle the logic in like our require statements?
Yeah, that's another way to do it. So like what they're doing, instead of using requires, they're just using if statements. But you can do that as well. But I think the most important thing to do is always make sure, if you're like sending money to another contract from a contract, update the state of your contracts before you actually send the money, because that just prevents it from being an issue. Because someone can like re-entry call it, but they'll just be withdrawing money that they have, and if they run out, they won't be able to call anything. Cool. All right. Let's try one more. Another thing about auto reports is it's okay if you don't understand everything. Like you won't understand everything in an auto report. I still don't understand everything in auto reports that I read. But it's always good to just come up with some takeaways. So now that you've been exposed to a few different attack vectors, you can just look for those in auto reports. Like we just did, we saw a reentrancy guard. Is there another one that? Yeah, I guess we pick another one to go through. I think that was a helpful exercise.
I mean, you haven't talked about this, but time lock, I think, is an interesting one. The N06.
Yes. So, let's see.
I had seen people talk about this for a long time, and I didn't understand what a time lock was until I spent some time just looking it up the other week. I think it's a good thing to have.
Yeah. And this is one of those issues where it could be like a comment, but you could also have like a low, you could have a medium. And it just depends on what the time lock is allowing. So in this case, it looks like, so I'll click on the code real quick. So inside of this function, so this is a ERC 721 NFT. Oops. Okay. Yeah, could someone give a quick run through of what this what N06 is saying, what the recommendation is, like why it makes sense?
Yeah, I mean, I can basically say my understanding of it. So basically, the whole point of putting a time lock on a function is to give people time to get their funds out if they think that it's an exploit is in the process of occurring.
Mm-hmm.
You know, you can have, like, for instance, they list transfer ownership. So like maybe the contract's the owner is getting changed to a malicious actor. And if there's no time lock on it, that can immediately happen, and then the malicious actor can carry out whatever exploit they wanted. But if there's a time lock on it, everyone can see it, and they can see that it was malicious, and they can start to take actions to protect their funds and get them out before the exploit occurs.
Yeah, exactly. Time locks are very helpful in a lot of cases. Cool. Yeah. Yeah, they definitely encourage you, if you haven't had a chance to read through this, just trying to pick up a few, like reading through a few of these, just trying to pick up some things along the way. Cool. Okay. So that was everything that I had scheduled for this session. In terms of the assignments for this section, I think the next CTF is level 3, is coin flip, and the optional CTF is reentrancy. And I think this is the first CTF where you have to write the solution in Solidity. So I encourage you to either use Remix or Hard Hat. And Miles and I would both be available on Discord and in the study hall next week to help out if you get stuck there. Also, if you have some time, I added another auto report to read. So you can essentially do the same thing we just went through, where you look through a few issues to try and, find the attack vectors we've already talked about and learn like how they actually show up in real audits, or you can learn new attack vectors. And again, there is a repository for this course. It's on GitLab's organization, and all of the descriptions for assignment 3 are here as well. Other than that, anyone have any other questions or thoughts, things they wanted to go through?